Assalamu alaikum everyone. This is a IoT based project about smart home control using eye-blink detection. So here is our team introduction. I'm Zahir and with my fellows and we are student of BS Computer Science at University of Sialkot and our supervisor is teacher Asia Mumtaz from Department of Information Technology. Here is an introduction of our project. This is a smart home system is designed for people with physical disabilities, enabling them to control appliances like lights or fans by simple blinking their eyes. An IR sensor mounted on glasses detecting the blinks and sends signals to the Node MCU. Here we are using ESP8266, which can control a relay switch to turn devices on or off. The system is also supported using via Blink IoT app, allowing users to operate appliances smoothly through their Wi-Fi. This dual control method, Blink based and app based, offers greater independence, comfort and easy to use. So basically we design a system for the people who have physical disabilities and they just wear glasses and by blinking of their eyes they switch on or off the appliances like bulb or fan. So here we have a short diagram about our project. We're using these components like IR sensor, wearable glasses, Node MCU, a buzzer and a app setup that is Blink. So here is our problem statement that we discussed before. People have many disabilities like uh, physical disabilities, so they're not able to turn on and off the lights or any home appliances. So we design a project, glasses that control the whole house by just blinking their eyes, and that's we write over here. And here is the solution we also discussed before. We we just too we just blink too quick and for turning on and off the home appliances, and our system is work on two phases, like one for offline and one for online. Like we integrated a app setup on our project. We just turn on and off the lights or home appliances by using our mobile phone or our web application. And offline setup, we turn on and off our home appliances by our glasses will places on our eyes. Our project goals is to help people who have physical disabilities to control home appliances such as light or fans. The system is especially beneficial for individuals who cannot use their hands or voice. The project is use affordable components like Node MCU, IR sensor and relay and buzzer and these all things. So here is our project objectives. We enhance abilities, gesture based alternative and intuitive logic and remote control. We just control our project by the mobile and our logic is very simple, and provide a hand-free option to conditional controls and enable smart homes control for disabled or elderly users. Here's a short system overview. On our system overview, we use a IR sensor on glasses, a dual blink detected algorithm that we place on our MCU, and a node MCU processing which gives signals to relay and buzzers, and a relay module that triggers the bulb on or off for any home appliances, and home appliances that is a bulb that we use. And these are all the components, and the key components are we use the exactly components that we use. we use a IR sensor. We use two IR sensors that we place on our glasses. The model number is TCRT 5000, and we use a Node MCU. The type of Node MCU is ESP8266, one channel 5-watt relay module, a buzzer for feedback. When we turn on and off our appliances, we receive a signal from our buzzer, and a breadboard with jumper wires. We use jumper wires male to male and male to female, and also female to female, like 10 pieces for all, and 5-watt external power supply, and a smart light bulb or LED. We use a bulb and a glasses frame. We put the IR sensors on glasses frame and on software. This all things for offline setup, and we use online setup. Our software Arduino IDE, Blink mobile app, and Blink web dashboard, and serial monitor for debugging. On the hardware components, first we have the glasses. We place the IR sensors. Basically, on the IR sensor, here we have two lights, one for infrared signals consumption and other for the creation of infrared signals. And these are two lights. The black one is for consumption, and the white one is for produce, the infrared lights. On the IR sensor, here we have a controller that controls the distance, like how much distance we use to provide the signal to the IR sensor. And here is our glasses. We just place a IR sensor on our glasses, and by using female to female wires, we connection our glasses with our breadboard. And here we have a breadboard. Here is our Node MCU, Node MCU 8266, and this is a Node MCU 86. We have the pins over here, the D1, D2, D3, and other pins, and we just provide a supply from our computer to Node MCU over here for checking the signals from a serial port. And we have a relay. We just put a relay and a buzzer, a 5-watt buzzer, and we just connection by the wiring. So how we did connections? The connections are very simple. We provide a short summary to you on screen, and here is the connection. We just connect the IR sensors. The IR sensor have 3 pins, like VCC, ground, and out. VCC basically is a positive connections that we provide for current, and this is a very simple way to providing the connection. We have an external supply on breadboard. We have the positive and negative terminal. These lines are working with rows, and these working with columns. Like if we provide a one connection over here, all these lines have the same connections. And this is very simple. We just provide external power watt supply by this and a charger. We put over here the connections, and we did the positive and negative terminal. We just convert the supply from here to here by just a male to male wire. We put a male wire over here, and then here a male. We just a rail of this is the positive rail, like for VCC, and this is a negative rail for ground. Okay, our ground remains same for each and every component, like buzzer, our IR sensors, because this is necessary to complete our circuit. And here we have a relay. So now let's about the connections. So we have two IR sensors, the left and right one. By the left one connections are VCC, ground, and out. We just connect the VCC to external 5-watt supply. Ground remain common for all. Here is the ground, and out we put on D1, because Node MCU produce signals. We receive signals from here by eyes. Our IR sensor put the signals to our Node MCU by D1. Here we have a D1 connection. We just show you. Here we have the D1, D2, D3, and D4. So same for the IR sensor, but here IR sensor right, but here we have a connection for right one. We did VCC and ground same, and our D2 pin with D2, and our D2 pin with D2, and for the buzzer we use pin number D4. The buzzer VCC, the red wire goes to D4, and the black one is go, here we have the black one wire is go for the ground, because the ground remains same for all the components. And on relay we have different kind of pins, like we have in, ground and VCC. Here we have in, ground and VCC. The VCC goes to same external 5-watt supply, ground also, and in pin goes to D5 on the MCU. Here we go, here are signals. Basically this is a brain. The brain gives signals to relay to trigger on or off. And on other sides, here we have two ports known as COM1 and NO1 and NC1. NC1 we not use because this is normally closed, and NO1 used for the positive terminal of the bulb. Here we have the positive terminal of bulb, that is the wire, and it goes to positive terminal of the bulb. And the negative of bulb is directly from our ground, because this is necessary for the circuit. Now just providing the powering to our system, and we will show you how our bulb triggers on and off. So now we provide the external supply to our system. Here is our blink app connections. You know, the status of our application is on. We can control our bulb state from here. We just off the light, and our light that is over here is off. And if we turn on the light from the application from here, like we on, and our bulb become on this condition. As you see, our bulb is on. And that's all. That's all introduction about our project. We see you again. And this is our bulb. We just turn on and off from here. We off, and our bulb become off. And if we on the bulb become on. You see from here the bulb on. And this is our whole project. And these are devices that help. And our buzzer beep did sound of beep 2 or 3 times when we are on from application or app. And here is our glasses. We use our fingers instead of our eyes over here. We use our eyes over here, like we just place it, and our bulb remain on and off. Here is a serial monitor on which we see the status. Now our eyes remain on. It shows the live status. Both of our eyes on, because we not put the glasses over here. If we put our glasses, like if we put a object, then it shows the status. If I put the hand on our sensor, like for left, and now the left one is blinking and right one is off. If we put right one is blinking and left one is off. If we put two quick blinks from our glasses, the status will change. So this is our project. And here is our detection logic on which we made a algorithm. We design, like our eyes blink every time. We just make a logic to we just make a code, like it used millis of seconds to detect our blink detection. If we did 2 quick blinks, like with the 300 and 500 milliseconds, then it triggers the relay to turn on and off the lights or any home appliances. Otherwise, a fast trigger or slow movements or continuously presence, we just simply blink our eyes easily. And here is the result and future scope. We have achieved research accurate dual blink detection, reliable relay switches, effective offline and online control, and low power consumption. Here's a future enhancement for our project: advice recognition integrated with Google Home or Alexa. We just integrate with Alexa to find out how to we just turn on and off like by just commanding our Alexa or any devices, and add temperature and humidity sensors to measure the temperature around the area of our system, and we just improve the design and packing of our system. Like it is we maybe we just convert into wireless, that our glasses is just put on faces and we just move and everywhere. Now we have a not a wireless setup, but it's good for peoples. Here is a conclusion: a smart solution for accessible and convenience, combining gestures control with IoT, designed for inclusive reliability and simplicity. So thank you. That's our project.